2.0 grams of a monobasic acid was made up to 250 centimeter cube with distilled water. 25.00 centimeter cube of this solution required 20.00 centimeter cube of 0.1 molar sodium hydroxide solution for complete neutralization. The molar mass of the acid is dash. Solution. In a question given in this format, the first thing to do is to write out the chemical equation that is showing the reaction between the acid and the base. But here we are not given the acid rather. We just made to understand that it is a monobasic acid. So a monobasic acid is acid that has its basicity to be 1. So let's represent the monobasic acid with X. So if X is reacting with the base now is sodium hydroxide, then we'll be having a salt and a water according to neutralization reaction. So the salt will then be NaX plus H2O. Looking at this, we'll discover we might want to say it is not balanced, but at the same time it is balanced. How? This is sodium. We have one atom of sodium here, one here as well. One atom of oxygen here and one as here. So we have one atom of hydrogen here and 2 atoms of hydrogen here. So see here we have 1 and we have 2 here. The acid here, X, will also be having 1 atom of hydrogen because it is a monobasic acid. So 1 atom of hydrogen present in this acid with 1 atom of hydrogen here will make it 2 to give us 2 atoms of hydrogen in water molecule. So hence we can say this equation is balanced. The next thing to do is to write out the formula we'll be using. And don't forget that any question that has to do with neutralization reaction or titration, we'll be using the formula that says CAVA over CBVB equals NA over NB. So where Ca is the concentration of the acid in mole per dm cube, Va is the volume of the acid, Cb is the concentration of base in mole per dm cube, Vb is the volume of the base, Na is the number of moles of acid, and Nb is the number of moles of base. From the question now, our Ca is unknown. Let's continue. Va here is 25.00 centimeter cube. Cb is 0.1 molar. Vb is 20.00 centimeter cube. Na is 1, that is the coefficient of the acid, 1, and Nb is 1 as well. So let's proceed. Ca is unknown. We'll be making Ca the subject of the formula. Ca equals CbVb Na divided by VANB. So let's substitute the values. We have Cb 0.1 molar multiplied by 20.00 centimeter cube multiplied by 1 divided by our Va 25.00 centimeter cube multiplied by 1, that is the number of the moles of the base. We have 2.0 divided by 25 molar, which is equal to 0.08 molar. So we've gotten the concentration of the acid. So, and that's not all. Let's go back to the question. We have to calculate the molar mass of the acid. And from what we've done here, we've just calculated the concentration of the acid in mole per dm cube. So how do we go about the molar mass of the acid? To do that, we'll be using the formula which says molar mass equals mass concentration divided by molar concentration. Now we've known the molar concentration of the acid. The molar mass is unknown, and that's what we are calculating now. But the mass concentration as well is unknown, yet it can still be gotten because we've been given the mass of the acid present in 250 centimeter cube. So to get the mass concentration of the acid, like the concentration of acid in grams per dm cube. So we'll say we have 2 grams. According to the question, we have 2 grams of the acid, 2 grams of the monobasic acid. It's present in 250 centimeter cube. So how many will be present in 1000 centimeter cube? That is, what mass of the acid will be present in 1 dm cube? So we say x grams of the acid is present in 1000 centimeter cube. So we find x here by cross multiplying, but we won't be showing that. So we just say x equals 2 grams multiplied by 1000 centimeter cube divided by 250 centimeter cube, which is equal to 2000 over 250 grams, which is 8 grams. So hence we can say that concentration of the acid in grams per dm cube is 8 grams per dm cube. So we've gotten the concentration of the acid in grams per dm cube, and we've gotten the concentration of the acid in moles per dm cube from the previous calculation we did. So we can proceed, and we can say the molar mass of the acid from the formula. We have mass concentration, that is concentration in grams per dm cube. So the concentration in grams per dm cube of the acid here is 8. So we have 8 grams per dm cube to be divided by the molar concentration. So the molar concentration, we've gotten 0.08 molar. So divided by 0.08 molar. So here we have our answer to be 100 grams per mole. So let's not forget that molar is the same thing as mole per dm cube. So that's how we come about the units to be grams per mole. So here now we've answered the question. Hence we can say the molar mass of the acid is 100 grams per mole, and that will be all on that.